Here we have some data for Michael Jordan 1993 playoffs. And you can see it all listed here game by game. He played 19 games, and the point total in each game is shown here on the table. So this is our basic data. If you're thinking about this as a statistical study, then the subjects are the games, right? We're taking data from each game. And the data that we're looking at, the variable that we're looking at, is Michael Jordan's point total in that game. So this is our column of data. Points is the variable of interest. And what we'd like to do here is think about the center and the spread of the data. And we'll work through the calculation of standard deviation. Now, I'll say right away that in practice, you'll never calculate standard deviation the way that I'm going to do it in here, but I want to do it this way to understand the formula and also introduce some important formulas in Excel. So let's start here at the top. We've got the sample. So in the standard deviation formula, the sample size is important, how many data points that you have. So we need to know the sample count. Now I know that there's 19, so I could just write 19 in here, but I'll also show you a trick, that formula that you can use in Excel to calculate the sample. So if I click on this cell and I type equals, that tells Excel that I want to calculate something, so it's a formula. So I type equals, and then I want to count how many data points there are, so I'll use the function count. So I type in count, and then in parentheses, I can put in what I wanted to count. And so you'll see once you type in a formula in Excel, it'll tell you what to put in. And so it wants a series of values to count. Now, I could just put them all in one by one, but that wouldn't be very efficient. So instead, what I can do is I can just click on this first cell, and I'm still holding down my click, and then I'll drag down the column for all of the data. And so now I've counted, so now I will have counted everything that's in this highlighted region, close the parentheses, click enter, and it counts that there are 19 data points in here. So the function for counting things in Excel is just equals count. Now let's look at this formula a little bit more closely. So I did it by clicking and dragging. You can also just type this in. So B5 colon B23 means count everything from cell B5 to cell B23. And so everything in the Excel spreadsheet is organized by row and column. So this is row 5, this is column B. And so we're starting in cell B5, and we're going up to cell B23. All right, so that's our count. Our sample size is 19. The measure of center that we're going to think about here is the mean value or the average value. Excel calls it the average. So I will type equals average. And then same process here. I want the average of the same data that I just counted. So I can click and drag over that data, close parentheses, enter, and now I have the mean value. Now, Excel will default to a certain number of decimal places here. Maybe I don't care so much about whether it's 35.0526. Maybe I just want to keep like one decimal place. You can go up here and change where the decimal place, how many digits after the decimal place goes. So if I click this one, it'll decrease the decimal place. So maybe 35.1, I can round that. And then really what I'm looking for is precision to that first decimal place. If you want more, keep more. Okay, so I have the sample size, I have the mean value, and now I want to get to calculating the standard deviation. So let me come over to the PowerPoint slide where we have the formula, and this data is all here again, so it's the same data. And this is the formula for standard deviation. It's complicated looking. We have square roots, we have a summation symbol, we have this symbol here, which means the mean value. But what we're actually doing when we calculate a standard deviation is something fairly intuitive. What we want to do is find out on average how much does data vary from the mean value. So if the standard deviation is big, then you have a lot of values that are very different from the mean. If the standard deviation is small, then the values are all pretty close to what the mean value is. So x minus x bar is what we would call the deviation. The deviation between the value of a particular data point, which is called x, and the mean value, which is the same, which we just calculated was 35.1 for the Michael Jordan data. Now, the rest of the stuff that's here is there for a specific reason. We want to square it and then ultimately take the square root, because we don't care if the deviation is positive or negative, right? We just want the average amount of deviation. And if we didn't do this squaring and then square rooting, then that deviation would just average out to 0, because you'd have some values that are bigger than the average, some values that are smaller. When you sum them all up, they would cancel each other out, and you just end up with 0, and you don't get the information that you're looking for. So by squaring it and then adding it up, this thing here, summing the squares, that's called the variance. And once we do that, then we just need to take the square root at the end, and it gets it back into the same units as the mean had. And then we divide by n minus 1. N is the sample size, and it's minus 1 for a somewhat complicated reason that I'm not going to get into right now, called the degrees of freedom. We'll talk about degrees of freedom later on, but for now, just know that there's an n minus 1 here in the formula for a standard deviation. Okay, so we need to calculate this. The deviation squared, add them all up, divide by n minus 1, take the square root. All right, so I've created a column here in the spreadsheet for calculating the deviation squared. So what I want to do is equals, and then I want the difference between this value and the mean value, 35.1, and then I want to square it. So I'm going to put this in parentheses. I want to click over here. I want that cell minus the mean value. Now I have a choice. I can click on this. I could just type in 35.1. I'm going to click on it and then square it. So squaring symbol is the little caret operator. So like the upward arrow is to raise to the power, and I want to square it. So it's raised to the power of 2. And then I hit enter. And it calculates that deviation squared. Now again, it kept a lot of digits. I can reduce that if I want to. I'll just leave it as is. We're not going to think too much about these individual numbers. Okay, now the advantage of using a spreadsheet is that you do the calculation once and then you drag it down, and it will do the calculation for you as many times as you'd like. But there's one more thing I need to do here, and one more thing I need to think about. So let me go back into the formula. I want it to take what's in this cell, subtract what's in this cell, square it. Each time, I want it to take this value and then use this same mean value in the calculation. So I don't want this to change. When you drag down a formula, Excel is going to update this. So it's going to go from B5 to B6, from B6 to B7. I want the B3 to stay the same, and the key to do that in Excel is you can put dollar signs around the B. It will stay the same value. Now, alternatively, I could have just typed in the number 35.1, but then if this value changed, like I made a mistake, I would need to go back into this formula and fix it. Now, if I change this here, this will update automatically. So this is just a little handy trick to use to simplify things. Okay. So I've got dollar signs around the B. That means keep it in the same column, and dollar signs before the 3 means keep it in the same row. So this cell will stay the same for each calculation. And I'll show you that that works by dragging this formula down. Okay. Let's see why it gave me these dollar signs here. Just because it had too many digits. So let's reduce the digits a little bit. Okay, that looks better. All right, so I'll click on a random cell here. Let's go to this one here, 170 squared deviation. You don't need to think about what this number means very much, but look what the formula did. It took what's in cell B14, so that's right here. It subtracted cell B3, so it kept this one the same, and then squared it. So we have all the square deviations. Now what the standard deviation does is it adds up all of those values. So I want to add up all of these values. And the formula for that is equals sum. And now I want the sum of all of these values. Okay, so I did that. Sum C5 to C23. We're adding up all of these values. Enter, and I have that sum. So back to the formula. I figured out here what's in the numerator of this fraction. I just calculated that manually. Calculated what that is. Doing each deviation squared, and now we've added them all up. So I want to take this, I want to divide it by n minus 1, and I want to take the square root. So for the standard deviation, I want equals. I'm going to take the square root of everything. In Excel, that's SQRT. So SQRT, open parentheses. What am I square rooting? I'm square rooting this number divided by n minus 1. The sample is 19, so that's the n. And I'm going to put this in parentheses too, because I don't want it to divide by n and then subtract 1. I want it to divide by n minus 1. So I'm going to divide by this minus 1, close parentheses, close parentheses. That's my full formula for the standard deviation, done manually. Okay, 9.85. Not a whole lot of fun, right? That was a pretty boring exercise that we did here to calculate the standard deviation, but we do have the value. The value is 9.85. So we have a mean of 35.1 and a standard deviation of 9.85. If you didn't enjoy this process of calculating standard deviation manually, you're not alone, and you don't have to do it that way. So let me right next to this do the standard deviation using Excel's standard deviation formula. So I can do equals STDEV. That's the standard deviation formula, open parentheses. And now I'll go to the original data, highlight the original data, and it will calculate the standard deviation of that column of data. So just like I did for the mean, instead of writing equals average, I write equals STDEV, and I get the standard deviation, 9.85153. So same number, a lot less laborious of a process. I went through it this way so that, one, you'd understand what goes into the standard deviation formula, but two, you also have a little bit more appreciation for these spreadsheets and how they can really simplify what you need to do. Once you have the column of data and you know how to use these little functions in Excel, like equals average, equals count, equals sum, equals STDEV, then you can get the answers that you're looking for pretty quickly. Okay, so that's the standard deviation part. A little aside here. If you want to visualize what the data looks like, one tool is the histogram. And in the histogram, you need to have bins decided upon. And I'm going to make this histogram manually by counting how many data points fall in each bin. And so I selected bins 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59. By looking at the data here, I have point totals that go up to a maximum of 55. And so I need my bins to span that range up to including 55 points. And you always want to have fewer bins than you have data points because you want to be able to fill the bins up with data. Now, if you have too few bins, then your distribution isn't going to show its shape very well. So there's a balance there. You want enough bins where you can see the shape of the distribution of data, but not so many bins that there's only a couple of data points in each bin. So now we go through and need to look at the count, 0 to 9 and so on. So in the 0 to 9 range, I don't think there's any data points. So that one's going to have a frequency of 0. 10 to 19. So now we're looking for values in that range. So we have 18, and so there's 1 in that category. In the 20s, how many data in the 20s? 1, 2, 3, 4, 5. So there's 5 in that bin. 30s, 1, 2, 3, 4, 5. 6, 7. 40s, 1, 2, 3, 4. And then the 50s, 1, 2. So hopefully, I might have miscounted, but I can check to at least see that I have the same total. I'll highlight these cells. That's my frequency. So that's the number of times values fell in each one of these bin ranges. And when you highlight cells in Excel, there's this little printout on the bottom here showing you the average, the count, and the sum. And so it sums to 19. I have 19 data points, so I think we counted correctly. All right, so I've got my bins, I've got my frequency. I'm going to highlight this table, insert a bar graph. And so there's all sorts of charts here. The bar graph option is this one. I'll come back to this one, which looks similar in a minute. You can pick any of these. This is more your aesthetics, which you like. You know, do you want it printed sideways? Do you want it vertically? Do you want it 3D looking? Let's keep it simple. Okay, so this is our histogram of Michael Jordan's point totals in 1993. We can see it has that sort of bell curve shape, which you might be familiar with. Topic for next week. The peak here is in the 30s, so most of the data fell in this bin. And then it sort of trails off to either side. It's fairly symmetrical looking, which means that the average value is a reasonable choice for the measure of center since we have a symmetrical distribution. Now, last point, and then we'll stop this video here. You can make histogram using the Excel automatic tool for making histograms. And so if I come to the data here and I highlight the point totals, I can insert a histogram. And that brings me to this tool. This is for its statistics graphical tools. We'll use some of these. One of them is the histogram tool. You click on it. It does not give you a lot of flexibility in how you make it, so it makes it how it wants to make it. And you'll see now why I chose to make mine myself. Because it has such a small amount of data here, Excel decided that you only really can have 3 bins. And so its bin choices were from 18 to 31, 31 to 44, 44 to 57. So it made bins of size 13. There's an algorithm that it uses, but you don't have the ability to customize it how you like. And so you can see these look very different based on how you've divided the bins up. So I don't personally use Excel's histogram tool very often. If you have a lot of data, then it gives you a reasonable printout. When you're dealing with a smaller number of points, say like less than 50, then it doesn't make very useful looking graphs.